Okay, so now let's continue to look at a couple of examples here. Number 6, so 7 secant cube x dx here. So to handle this problem, you need to know that secant square equals 1 plus tan square. Okay, that's the first thing you need to know. Also, the derivative of tan equals secant square. Those are the two that you need to know ahead so you can figure out this problem. And the idea is simple. First of all, I split this one into secant square, and then I'm starting to use this trick. The 7, I can use this one into 1 plus tan square, okay. And the secant square dx actually equals the derivative of over d tan x. So right now, do you see that it's going to be a super easy integral to evaluate? That is 7. So it's tan x, right, plus tan cube x over 3 plus arbitrary constant c. So you can check. So 7 tan x plus 7 over 3 tan cube x plus c. So the answer is D. Easy. Alright, so number 7. Use this side. Number 7, it's okay, integral 7 over 1 plus 49 t squared dt. Okay. So to handle number 7, one thing you need to know is 1 over 1 plus t squared dt equals tan inverse of t plus constant c. So that's the first thing you need to know ahead. Once you get that, this one is super simple. Now let's see. So 7 over 1 plus, I can do 7t squared dt, right? So easily you can see that I can make a u substitution. So set u equals 7t, then du equals 7 dt. Since t is from -1 to 1, so my u is coming from -7 to 7. So make their substitution. So -7 to 7. So 7 dt is du, right? So it's gonna have 1 over 1 plus u squared du. So you realize this is in a perfect format. So I'm gonna have tan inverse of u, -7 to 7. So we're going to have tan inverse of 7 minus tan inverse of -7. So if this tan inverse is an odd number, so this becomes into negative tan inverse of 7. Negative and negative become positive. So turn that as a 2 tan inverse 7. That's my answer, okay? And we can go back and check to see, do we have that? The answer is, yeah, we have it. Cool. That's number 7. So this, I think 6 and 7 are the problems of the integration with the trig geometry substitution. Number 8, let's see. Number 8. Cool. So number 8, it's another problem with the trig substitution. So let's see. We have integral 0 to 1 dx a1 minus x squared. Right. Okay, so regarding to this scenario, what do we need to do is 9 squared minus x squared here. So one of the substitution when you have square root of r squared minus x squared here. So the substitution you're going to observe is you're going to set the x equals r, which is the, in our problem it's 9, times sine of theta here. Okay. And of course, theta is going to become into sine inverse of x over 9. Okay. We're going to use that. So why we do this? Because dx is going to become into 9 cosine theta d theta here, right? Okay, so and then when you do the substitution into here, oh, and by the way, when x is from 0 to 1, and then the theta again is going to become from 0 to sine inverse of 1 over 9. Okay. And then dx, it's 9 cosine theta d theta, right? We have it here. Bottom, 9 squared minus 9 sine theta squared. So eventually you will see that on the bottom, it's going to give you its 9 cosine theta here. Because under this part here, this is, all this part is going to be positive. So you're going to have inverse, it's 9 cosine theta d theta over 9 cosine theta. And turns out, cancel, right? D theta, and our result, super duper simple. So it's just a sine inverse of 1 over 9. That's it. So it's easy one. So let's see, do we have this sine inverse of 1 over 9? The answer is yes, sir. We have it. Okay. Cool. So this is the other problem. Number 9. Let's see what we can get. Use a new page. Number 9, 10, and 11. It's the problems involved with this partial fraction decomposition. So you have 6x plus 3 over x minus 4, x minus 1, so that's 9. So when we do the partial fraction decomposition, and then you're going to see it's a over x minus 4 plus b over x minus 1. So the numerator part, numerator match. So if you let them to have the same denominator, you're going to have, right? So that you're going to have this. So you know that the numerator and numerator must match. So 6x plus 3 equals ax minus 1 plus bx minus 4. So it's ax minus a plus bx minus 4b. 6. So you can see it's a plus bx minus a minus 4b equals 6x plus 3. So 6 equals a plus b, 3 equals negative a minus 4b. So this is the system of the equation. Easily you can solve that. So if you add them together, you're going to have 9 equals negative 3b. So b equals negative 3. A going to equals 9, right? So it's easy. So we can check 9 over x minus 4 plus minus 3 x minus 1. So the answer, it is b. Okay, so that's number 9. Number 10. 3x plus 19 over x squared plus 8x plus 15. So immediately, this is what we can get. And we're going to use the exactly same logic to attack this problem. So it's a over x plus 3 plus b over x plus 5. And based on the match of the numerator, so which I directly write it out, it's going to be a times x plus 5 plus b times x plus 3. Okay. So it's a plus bx plus 5a plus 3b. So hence you're going to have it's a plus b equals 3. 5a plus 3b equals 19. So again, system of the equation, easy to solve. So I have 3a plus 3b equals 9, right? So I multiply 3 on the top and then do a subtraction. So you're going to have 2a equals 10. So a equals 5, b equals minus 2. Okay, so I'll go back to here. We're going to have 5, right? And minus 2. So the answer is going to be C, right? It's going to be C. Okay. And that's 11. That's 10. Number 11. Couple of them. It's square. Okay. So you need to be careful here is, this is what we call the repeated factor. So the inside of the parentheses degree, it still is 1 here. So when you do the decomposition, it's going to be in increasing order, but on the top are still 1 degree less than the factor, which is x plus 2, which if it's 1 degree less, it's going to be, both are constant, okay? Okay, so with that in mind, things become pretty simple. So it's a x plus 2 plus b, that's the numerator, right? And so x plus 2 squared equals x plus 5 over x plus 2 squared. Hence, x plus 5 equals a times x plus 2 plus b. That is ax plus 2a plus b equals x plus 5. Easily you can get a equals 1, right? So it's 2a plus b equals 5, so b equals 3. Simple. So it's the answer should be C, right? That's number 11. So hope you like it. Thank you.